Video clips will cover the security allocations of Markowitz full covariance model. Once you finish the capital allocation and the asset allocation, we want to find the efficient frontal line of the securities that will be included in the risk asset portfolio. So the starting point here, return, and gathering the information of return, which is mean, and the risk, which is standard deviation. We are using the ETF funds here in Sweden, Hong Kong, Italy, Japan, Switzerland, Spain, Mexico, and US. And we gather this historical the data, the mean and the standard deviation. We also need to collect the correlation coefficient of the two the different the ETFs, and we gather the information here, right? This is what the junior analyst does, and they put this information from their historical data. Once we got the correlation matrix between the risky asset, risky investments, risky securities, then we need to build the covariance matrix. How to calculate covariance matrix? Yeah, there you go. Here, the correlation coefficient between two assets times, now, right, this is standard deviation of the two assets, risk assets. So we calculate this covariance co-matrix. We don't want to spend a time here into this calculation. So each the covariance matrix is now calculated by this equation that we the practice last class. Once we complete this, the data, the correlation matrix and the covariance matrix, then we need to get this boarded covariance matrix, assuming that the equally weighted portfolio. For example, if we assume the 100% of the investments is from this, how many options do we have? Like eight. Yeah, 8 countries, 8 the ETF funds. So we just divided 1 by just 8, right? So the same 12%, sell 12.5% we invested, so that the total weight is the 100%. And the row line also has the same, right? Same, the equal weight. Under this equal weight of investment in the risky portfolio, what can be the portfolio characteristics, portfolio variances, and portfolio standard deviation, portfolio, the expected rate of return. First, let's calculate this, the equally weighted portfolio. As we discussed during the class, we calculate the weight. Again, always the portfolio management is to calculate the weight of the individual assets, weight of the individual securities. Because of this, the collecting data from the return or the risk or correlations is too much subjective, right? Too much subjective. But as long as we got this information from like meetings or just discussions or any justification or assumptions, you got it, then the rest of the part is focusing on how we allocate certain percentage on each securities or each asset category, right? So here, portfolios, weight, here we each put some weight here. Once we get the board multiple covariance matrix, now we need to sum all this weight by these covariances. So the portfolio variances is just the sum of all this, the board multiply the covariance matrix. So here we'll sum all this up here, right? So let's calculate this board covariance matrix. So here, let me just use this part here so that you can see this. The formula, the matrix here, text formula. So equal, and first, I want you to use this equation here. Do you see here? The weight of this times. Now, here, which one do you want to use? Right, the covariance, right? The covariance as well as, right, this weight as well, right? Times, where is the covariance between Sweden ETFs and the US ETFs? Right, here we go. We put it here. But I want it to be very efficient when we create when you build this board covariance matrix here. We cannot calculate every single cells with these equations, right? Instead, I want you to fix this B column because we are going to drag it down. Also open the 44 because we are going to drag to the left or right, right? So you open the row here. Also here, J43, which is this weight. Also, I want you to fix this now, this row, because we are going to drag the right and left, but we'll fix this weight on the row 43. So let's just enter. So we got these covariance matrix with this weight, equal weight on the S&P 500 and the Sweden ETFs. So once you build this, now it's very simple. Drag down and drag to the right. So that we got all this boarded covariance matrix when we assume that equally weighted portfolio, 12.5% on each assets, each the securities. Once you complete this part, right? This part, then what is the portfolio variances? Portfolio variances, you can just sum, right? All this up on this standard the S&P 500. Sum of this all. This boarded covariance combination of the standard first 500 and right each the security. Let's just sum up. Now we got this, and then let's just drag it to the right. So these are the variances, right? Variances. Now let's sum all this up. What I calculate is portfolio variance. Now we sum all this up, all this combination of covariance with this each weight. So here, let's sum all this up. So the variances of this portfolio equally weighted is now 475. Now let's just square root of the variance. So this portfolio standard deviation, now we got the 21%. Then how to calculate portfolio average rate of return? Portfolio mean, you can use, right, the sum product of this weight, equal weight, times, we collected this mean here, right, at the top. Then we got this 14%. So this portfolio equally weighted with these 8 securities would be generating standard deviation 21% and a portfolio average expected rate of return of 14%, right? But here, now the point is, now we want to find this efficient frontier line, each individual asset. But here, if you're investors looking for the minimum variance portfolio, because above this line on this efficient frontier dominate, this below the line. So we'll create this efficient frontier line, right? So let's calculate this portfolio minimum variances. So how to find it? So let's get started from again the same process. We are going to update this, but let's get this. Again, the same process, the weight times weight times covariances. But I want to open only 62. I want to fix this column, but open this the row. So I want to fix this, and here fix on this row. Here the weight part, this weight part, and then enter. And let's just drag down and drag to the left. So we calculate exactly same result, but again, we'll update this, but we need to complete this older process, right? The same way, sum of all these covariances matrix, each combination, and then let's calculate the sum of all, which is the portfolio variance, and standard deviation is square root of the square root of this, then 21, and the mean is, again, how to get it? Sum product, comma, and the mean. Enter. So we have the same one, right? Same result here. But from here, what is the optimal level to find? What is the minimum level of the variances we achieve here? That's what we want to find, right? So we are using server here. Now, what is a server? Right, on the data, the server, click, and here set the objective, the standard deviation 21, minimum, right? Minimum. So I already created here. I already created this constant range, subject to the constant range, which is greater than 0 or 1. That means each invested securities must be less than 100%, not allowing short sales or borrowing, right? So here we set up here. What is the B70? B70 here, this must be 1, the sum of all. Again, we restrict this investment only the buy position, right? And then C74, what is the C74? Okay, here, C74, if we set this mean is now, if we set this mean is a 6, under 6, C74, this mean is a 6, it's a target rate of return, right? Target rate of return. What is the standard deviation? We minimize the standard deviation. Then let's just serve. Then here the combination 6. Now we have this. Okay. Here 19% or 1.9% on the Sweden, and 70% on Japan, and here what is P? Spain. On Spain, we will invest the 1.7%, and the US at 25.6%, where we can achieve the target rate of return 6% with the standard deviation 21%, right? So likewise, we have these cases when the mean is 6, 21, blah blah, likewise, right? But here, if we have the different formula, the combination 9% or 6% mean or 8%. So likewise, we can also set in this the server parameters. So if we set here, I'm changing this. Let's change this. 12, for example. 12, okay. and serve. Now, do you see, if we set this 12% the target rate of return, and the 17.926 is the standard deviation. Okay. So likewise, we can find all this efficient frontier line. Okay. Or if we want to find the minimum, then yeah, here we'll practice the minimum part here, right? So likewise, we can define all this, the combination of the mean and the standard deviation, and then we can create this efficient frontier line. Okay. So next video clip, we'll find the optimal portfolio that minimize the standard deviation or maximize the performance, which is Sharper ratios, to find the optimal portfolio in the next slide. Okay, see you in the next video clips. You guys, bye-bye.